Hello everyone. This is an 11 by 11 grid. And if you're asked to fill this grid out with ones and minus ones, and then for every row and every column, you compute the product of every element in said row or column, and then you sum all of those products up. Can you make that sum 0? So to do this, I'm gonna start by just filling in plus ones everywhere, and instead of writing +1, I'm just gonna write plus. So yeah, give me 1 second. Phew, that took a while. Alright, anyway, I'm done. Okay, so in this case, what would the product be on every single row and column? Well, this row is just 1, this is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and for the columns, the product is just 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And what would the sum then be? That would be 22. Now, if I were to exchange just 1 plus for a minus sign, then the product here would be -1, -1, and what would the sum then be? Well, it would be 20 minus 2, so therefore it would be 18. You see what happened? I subtracted by 4. That's what I did. And now, so we can note that down. Okay, if we have columns where the product is positive, if we have a square in which the column is the product of the column is positive and the product of the row is also positive, if we then exchange that for a minus sign, we will subtract the total sum with 4. Now, if I were to switch back, I would obviously, it would go back to 24, so I would add 4. Okay, so that's the first case where it says plus and plus and minus. And then if we have plus and minus, so meaning say plus in the row and minus in the column. So for example, that would be this square would fulfill those criteria. It has plus in the product of the row and minus in the product of the column. So therefore, if I switch this sign, if I get a minus sign here, then that would be a minus, and this would go back to a plus. And what happened here? Absolutely nothing. And if I switch it, and now we have the other case where, okay, so that was plus minus, and now we have minus plus, so minus in the row and plus in the column. And now if I switch that back to a plus, then yeah, I get a minus here and I get a plus here. And what happened there? Absolutely nothing. So now it's time to propose an invariant. If we call this number S, because sum, then my proposition would be S modulus 4. Because as we can see, the cases we just the cases I just showed you were in fact all, because you can just switching a sign only affects minus and plus, and it affects the minus and plus in row and column, so therefore 4 combinations, and that was everything that we just investigated. So therefore, these were all the options there were. We could change by nothing, or we could add 4 and subtract by 4. And since we were starting out at least at 22, we can say that our starting point, 22 modulus 4, that is 2. And since we can only change by 0 or plus or minus 4, then this thing never changes. It always stays at 2, and our task at hand was to fix so that the sum was supposed to be equal to 0. What is 0 modulus 4? It's 0. So therefore, this can never be. And proof concluded. So yeah, thank you so much for watching. Hope you enjoyed the video. Goodbye.